Hello, welcome from two students to our second lesson on your first topic, the structure of the atom. Today we want to look at the energy levels. Energy levels. And at the end, the objective of our lesson is that at the end of this session, you should be able to write the electronic configurations of the first 20 elements. Be able to write the electron arrangement of the first 20 elements. So we have said that in the atom, we have the nucleus. And the nucleus is made up of protons and neutrons. Protons are positive, neutrons are neutral. Then around the nucleus, we have what we call energy levels. And in the energy levels, we have our electrons. So electrons are found in the energy levels. The role of the neutrons in the nucleus is to bind the protons, so that the protons do not repel. Remember, like charges repel. But the reason why these protons do not repel is because of the binding effect of the neutrons. So the negatively charged electrons are attracted. These negatively charged electrons, they are pulled towards the nucleus. The positive nucleus attracts the negative electrons. But these electrons cannot collapse. They cannot move into the nucleus because of their speed. Their speed balances the attraction by the nucleus. So there's that balance, state of balance. Now, an atom, let us look at an atom. An atom is electrically neutral. When we say an atom is electrically neutral, it means an atom is neither positively charged nor negatively charged. An atom does not have any charge. That's why when we write sodium atom, we simply write sodium. We don't put anything up there. The charge is zero. We don't put a positive, we don't put a negative. The reason why an atom is electrically neutral is because the number of protons, which is the number of positive charges, equals the number of electrons. So the number of positive charges equals the number of negative charges. Therefore, an atom is not charged. Because if we take 10 positive charges and then we add 10 negative charges, it is like having 10 minus 10, which will give you 0. So the charge is 0. The charge is actually 0. Now, that is about. But now, how do we get? How are the electrons arranged within an atom? How are the electrons arranged within an atom? That is what we are going to look at. How are the electrons arranged? The number of electrons found in any energy level is given by 2n squared. If this is the nucleus, first energy level, second energy level, third energy level, fourth energy level. Like that. So the number of electrons found in any of these energy levels is given by 2n squared, where n is the energy level we are talking about. N is the energy level. So, if we are talking about energy level number 1, this energy level number 1, then the number of electrons will be what? The number of electrons will be 2 times 1 squared. That is the first energy level shell. That is first shell. Then we have the second shell. The second shell will be 2 times n. N is now 2 squared. So this one will give you 2 electrons. So the first energy level will have 2 electrons. The second energy level, 2 to power 2 is 4. 4 times 2, 8. We'll have 8. The second shell will have 8. The third shell will have 2 times 3 squared, which should be what? 18. But, so this one is supposed to carry 18. So that is how we calculate the number of electrons. So the maximum number of electrons that an energy level can hold at any one time, is given by the expression 2n squared, where n is the number of the energy level. But, however, when dealing with the first 20 elements, when we are dealing with the first 20 elements, we are talking about the first 20 elements. When dealing with the first 20 elements, the first shell can carry a maximum of 2 electrons. The second shell can carry a maximum of 8 electrons. The third shell can carry a maximum of 8 electrons. So this is what we are going to follow. We are not going to follow this because we are dealing with elements with fewer number of protons, elements with fewer number of electrons. So we are going to follow this rule where the first energy level can accommodate a maximum of 2. Second energy level can accommodate a maximum of 8. And third energy level can accommodate a maximum of also 8. So the first K, that is KLM, it is 288. That is the rule we will follow. Now, for the first 20 elements, I think I've said that, the following applies. First energy level is K shell, it has a maximum of 2 electrons. Second energy level, that is L, will have a maximum of 8 electrons. Third energy level, which is M, will have a maximum of 8 electrons. And then fourth energy level, which is N, will also have a maximum of 8. Now, if you look at potassium and potassium and calcium, they will behave in a unique way because of what is called expansion of the orbitals. I'm not going to go into that. So that is the distribution of electrons, KLMN, 2, 8, 18, that's 2. Then that is the rule of 2n squared. But in our case, we are not going to follow 2n squared. Now, let's look at the characteristics of an atom. The characteristic of an atom. How do you identify an atom? The properties of an atom. How do you look at an atom? We say this is an atom of oxygen. This is an atom of aluminum. This is an atom of nitrogen. So how do we identify atoms? There are 2 ways in which we can identify atoms. One is by using the atomic number. One is by the use of atomic number. So what is atomic number? Atomic number is the number of protons in the nucleus of an atom. Atomic number is the number of protons in the nucleus of an atom. And remember, when we are talking of atomic number, it is the same as the number of protons. And don't forget, we said that an atom is electrically neutral, meaning the number of protons is equivalent to the number of electrons. So we can see that atomic number is the same as the number of protons in an atom, which is the same as the number of electrons. Now that is one. Can have it there. Atomic number equals the number of protons equals the number of electrons. Then another characteristic is the mass number. The mass number. So the mass number is the sum of protons and neutrons in the nucleus of an atom. It is the sum. Sum means you add the number of protons plus the number of neutrons. Found where? Found in the nucleus. So this is how we get the mass number. So the mass number is defined as the sum of protons and neutrons in the nucleus of an element. So mass number, number of protons and number of neutrons in the nucleus of an element. Then, if now we are talking about mass number and atomic number, how can we present the elements so that we show that the elements have given mass number and have given atomic number? How do we represent these atoms? For example, we have sodium. We have sodium. We'll start up here. We have sodium. The symbol for sodium is Na. Atomic number of sodium is 11. Mass number of sodium is 23. So we can present sodium as Na. The mass number we write here as a superscript. Atomic number we write down there. So whenever you see an element represented like that, presented like this, then the superscript is the mass number. The subscript, which is the lower number, is the atomic number. So that is how we present. So you can see like this one. This is carbon. Mass number of 12, atomic number of 6. C is the symbol. Superscript, subscript. So example, the symbol represents an atom of sodium whose atomic number is 11 and the mass number is 23. So that is sodium atom. Sodium atom. Now, if that is sodium atom, which is Na 23, this is the mass number 11, atomic number. Therefore, if we want to know the number of protons, if you want to know the protons in sodium, then we simply say that protons is equal to atomic number. That's how we define atomic number. That atomic number is the number of protons. So if atomic number is 11, protons are also 11. Then if you want to get the number of neutrons in sodium, given this, what do? We know that mass number is equal to protons plus neutrons. Mass number is 23. Protons are 11. So neutrons will be what? Meaning neutrons will be 23 minus 11, which is 12. So this thing has 12 neutrons. That is how we work with, so atomic number, which is Z. Z is normally the standard for atomic number. It's 11. Atomic mass, 23. Number of protons will be 11, because protons equal to atomic number. Number of electrons will also be 11. Protons are equivalent to electrons. The number of neutrons will be A minus Z, that is atomic mass or atomic number minus atomic number. Then you get 12. So that is how we come up with the distribution of electrons in the different shells. So in our next lesson, we are going to look at the actual distribution of electrons in the different energy levels. That will bring us to the end of our lesson. Thank you for watching.